Hey, I'm Anfa. I want to show you how does the player authentication system work in Liblast, which I have implemented recently. So here I have the game client, and here I have an infrastructure game server. I've learned a lot of things about networking in Godot. For example, I am using low-level networking. I'm creating a inet multiplayer peer, and I'm not assigning it to the scene tree. Normally, with this, you would do in ready, you would basically do this. Assign the created multiplayer peer, the packet peer, to the multiplayer high-level multiplayer API of your scene tree. And this is what allows you to do RPC calls and use scene replication, etc. But I don't need this. And actually, the features of the high-level multiplayer are useless in this use case of communicating with an authentication server. So, by simply keeping it like that, I have the peer. So I have the inet multiplayer peer I created. Simple as that. I have a specified port for the infra server communication. Clients have the same port specified, and in the ready function, I'm first connecting, of course, methods to the signals coming from the peer for when a client connects and when a client leaves the disconnects, and I'm creating a server using that peer on the specified port, and this is the maximum limit of incoming connections. With the server, it's 4096 peers in the network, which is a huge number, and I don't think we will reach that amount of concurrent players anytime soon. So before I was also using this, and I was trying to do a low-level code, but I've learned, thanks to helpful people in the Godot contributors chat, I learned that the low-level multiplayer functions are not going to work if I assign my peer, to the high-level multiplayer API. So this pretty much is gone. So I've created the server. If there is an error, and there can be errors maybe if the peer already exists at this port, so the port is taken and cannot be used. Or some other weird things, like, I don't know, the port is blocked by some other application or something. Yeah, so I'm printing this just to make sure that the network peer the server has been created without issues. And then what comes in is the timer. The high-level multiplayer in Godot automatically pulls the incoming packet buffer in the multiplayer peer object. So this is the inet multiplayer peer. And using the low-level multiplayer, I have to manually check the buffer of incoming packets. So, for example, when I create a connection and someone wants to connect to me, I will only find out that someone wants to connect to this server after I do this. So I'm calling this timer every 10 milliseconds. So it's like 100 times a second. It could be 10 times a second. That wouldn't be a big problem. Or, I don't know, 20, maybe 50 times a second, 20. It doesn't really matter. I could just use a physics process, like to run it at a steady 60 frames per second, but I don't really need the timing to be super consistent on that. I just need to be checking the incoming packets frequently so I can respond quickly to clients that are trying to talk to me. So after we're polling this, you can also clean this up. After we're polling the packets, there is a method that tells us if there are any awaiting packets in our receiving buffer. If there are, so the number is larger than 0, then we just get the packet first in line, parsed as a variable, and we assign it to a new variable called request. Because, well, this is a server, clients connect to it to request something. That's why on this side of the server, I always call these incoming variables. Actually, it's a variant, incoming variants requests. Now, just in case something's wrong and we receive a request that is null, I don't know. This is actually legacy code. I could remove it, but it doesn't really hurt to make sure we don't process empty requests if somehow they go through. It doesn't hurt. So then I print, and I'm using print s. Print s is a special variant of the print function which inserts spaces between listed arguments. So instead of using this, I can do print s, and that's it. So Godot will add the space in automatically. You can also go print t, which will add a tab between all the arguments. And now the requests that I'm sending are formatted as an array, and actually this format may change. I am considering altering the format to make it a bit easier and more consistent. But how it is now is a request is an array of 2 elements. The first element is the header, which contains the information about what kind of request is that. So a request can be create a user account. If the header, which is the first item in the array, is create request, it's a create account request, then we process that as such a request. So we pass that request to player accounts, which is a singleton. In this infra server project, I've created a bunch of singletons. So we have database and we have player accounts. Player accounts has different methods for managing player accounts, and database is a backend for storing and retrieving data. So I forward this request to the player accounts, and I use the create player account method, and I now take the payload of this request, which is in the second item in the array, and the second item in the array is a dictionary, and that dictionary contains a couple things. First one is the username that we want to create, a hash of the password, a salted hash of the password of the username we want to create, of the user account we want to create, and the salt used to hash this password. So these are the 3 mandatory things that we need to know in order to be able to create an account. We store the results of that operation, and the player accounts create player account function is going to tell us if this succeeded or not. It's going to return a return code. It's going to give us a return code. Once we get that return code, we create a reply packet, and it's an array with the first element of the array being the header, and we just use the same one, create account, because this is a reply to this request. So a matching header makes sense. And the second item in the array, we send back the result, which is an integer. This is going to be 0, 1, or 2. And now, the cool part, we send this back to the client. First thing, we need to know who the client was, like who asked this. So I wasn't able to find an easy way to check like who sent the packet I'm processing right now. So I simply include the peer ID in the requests as like a return address. So it's the payload dictionary contains an item peer ID, which is a string. Actually, it's an integer, but it's a string that no, it's an integer. It's an integer that's like a unique address of the peer and the current current network. So I take my network peer and I set the target peer to that return address so that whatever I send now only is going to reach the client who has made this request. So I'm not sending this back to everyone because, you know, this is going to be an infrastructure server. There can be lots of connections. Lots of players will be logging in. Game servers will be constantly in touch with this. So we don't want to send this stuff to everyone. We only want to send it to the client that set the request. And that's it. We send it back. We don't care. Let's maybe take a look at the player accounts. So player accounts has a bunch of methods. We have create player account method. It takes the username, the password hash, and the salt used to generate the hash. Now, the first thing we do is we validate a username because there are specific rules that I've implemented for what a valid username can be, and the game client is already enforcing that. But maybe something goes wrong. Someone was trying to be funny and is circumventing that and still sends in malformed data. So I'm going to validate this data on the server side anyway. And this is what the validate username method is for. It's with an underscore to indicate that it's like a private method. It shouldn't be called from outside. This is just for use inside of this player accounts class or node. And we're checking if the username is empty. We're checking if there are any white spaces in it. We're checking if there are any special characters in it, excluding like the underscore and @ symbol, because it could be an email. So I think I should include @ because we don't want you to register with an email. We want you to register with username, and we can add an email later. We're also checking for super short, so at least 4 characters, at most 24, because you're not going to remember a longer username anyway. And I'm also checking for some common bad usernames, like if you're not allowed to be named any of that. You're not serious if you're putting this in. So any of these will result in a failed validation of the username. If none of these are true, if none of these conditions are met, the validation is passed. After it's passed, we go further. If it's not passed, we return an error number 3. Actually, it could be number 2 because 0, 1, 2. Yeah, that was a bad number. Never mind. And so when we create a player account, we need to create a record that's going to go to the database. So we create a record. The record is a dictionary and it contains fields: username, password hash, password salt, and also tokens. And tokens contains an empty array. This will store the session tokens, valid session tokens for this user that are currently in use. And the whole login process and authentication with game servers is based around these tokens. So we create this record and we tell the database to store that. So we take the database singleton, which is here, and we call the store method. Now the store method is used to put new objects into the database. And there are a couple tables in the database. There are 3 tables right now I'm going to show you. And the 3 tables are player accounts, tokens, and game servers. tokens is a separate table because we need to have a list of valid tokens that the game servers need to accept right now. And this needs to be quickly accessible. So we're actually going to be, sending them out and tracking it. So I think it's good to have just a global table of valid tokens, not just listed in the players, but everywhere. Okay, so when we create that, we store a new record into the player accounts table. The key under which we store this is a randomish number. It's not a random string, but it's a SHA-1 checksum of the username. This is so we're not using the usernames as our data references. I'm gonna show you. Hold on. Let me just open the database. Yep, there we go. Okay, so this is the testing database, and you can see these are the player account records. This is the table for player accounts, and the player accounts are not referenced by name. The player accounts are referenced by the SHA-1 checksum of the name, and this is to protect the usernames from being obviously visible, and also to uniform, make this uniform, and also make sure there are no weird things going on, the username. I don't know, potentially we're filtering it for weird characters, but if I missed something, there would be a problem. And here we can't miss anything because it's a checksum, and it has a non-valid, non-volatile format. And as you can see, for each user account, we are also storing the password hash and the salt used to generate that password hash, and of course the list of valid tokens. Here is a user that has 2 valid tokens, 1 and 2. And as you can see, they are also repeated here in the second table of our database, which just holds active tokens. And there is another active token here, which is for another user, which I named Anfa. And even if I used any, actually, I don't know, the passwords I would like to keep away, you can look at this file all day and you're not going to get my passwords from it, because yeah, you can't reverse engineer this. Sorry, not in a million years. And the last table is the game servers. It's empty for now because this is not implemented for the game servers yet. It only works for the game clients. Okay, clients and the infrastructure server. So the primary key for our record is the SHA-1 checksum of the username, and the actual record is here. We are checking, we are running this, and we are checking for output. If the output is okay, which means an integer 0, that means it was a success. So then we print, this is a helpful print just to debug, and I return 0, which means success. If there was an error during the database store, it's not going to return 0. So this check is going to fail. So this will run, and it's going to say this account already exists, because that's the only reason why database store will throw an error if the record already exists, because it does not allow for overwriting records. Oh dear, excuse me. So if the account already exists, we return 1. So the create player account in its entirety returns 1. And we go higher. This means the result is 1. So we send this 1 as a result. Let's now jump into the client. This is the client. Actually, you know what? Maybe I can run this and I'll show you in practice. I'm starting the infrastructure server. It's here. It has an empty window. There's nothing there. And now I'm going to start the client. It's here. So this is a UI I've put together. We can use a player account. Here we can log in or we can create an account. I'm going to create an account. We need to add a username. I'm going to go with blah. As you can see, I've implemented checks. The password needs to be at least 4 characters. Can't have white space. Can't have special characters. And also can be like, you know, yeah. Yeah, but we can call ourselves blah. That's allowed. Now the password, the only requirement is that it's 7 characters long, at least. We create an account, and it works. How does it work? We can look at the logs. So, by the way, our database is loading the testing file from disk, if it exists. Peer connected, so this client has connected to the auth server, and it's sent. We received a request to create an account for peer ID. This is the temporary unique identifier of this peer in this network. Username is blah, password hash is this, password salt is that. This is all we need to say. Give the info server to create an account for us, and there's a further comment, received request to create account, blah, 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 creating new testing database file. Oh, interesting. Why does create a new testing database? That must be a bug. Success writing testing database, successfully created player account, blah. Or, I think it's not creating a new, it's just making a, yeah, I guess in the store function. No. Interesting. Save testing file. Creating a new database file. Yeah, this is not true. Saving. Yeah, it's not creating a new file. It's just saving a file. It can be new or it can be old. It can be overwriting it. So yeah, that's just a bad message. It's not a bug. This is just a bad information. Success writing testing. So successfully created player account blah. So what happened is the info server has sent a request, a reply, and we can read about it here. So we're hashing the password. The password is 123 The hashing of the password took 32 milliseconds. The hashed password has been hashed using salt, blah blah blah, and the hash is this. So salt is this, hash is this. We sent a request to create the account. We got a reply, create account 0. 0 means success. And because we had success, the UI has animated and threw confetti in our face. And also it changed so that it locked us out from this. It says account created, and the cancel button is changed to proceed to log in. So we click, and now we can log in. So I'm going to put our blah and 1, 2, 3, 4, 5, 6, 7, and I hit login, and it says success. What happened? Let's see. Received reply to create account. Reply player login. Yeah, let's see at the. Let's take a look at the server side. So the server side is receive request to log in. Yeah. So you see, we've been here, successfully created a player account, blah. Now, we are trying to log in from our client, right? We clicked logged in, we login, we provided a username and a password. What happens is our client sends a request player login with this peer ID, which is what it is, and this username. Doesn't send the password yet. And that's because the client doesn't know the salt. Because like you as a username, you just downloaded the game on a new computer and you want to log in. You don't know the salt. You only know your username and your password. But to send the password over, we'll need the salt to hash the password so we can securely send the password hash so it can be compared. That's why this protocol I've made is so that the login request gives the username. We can look at this. Yeah, let's go in for server and on timer timeout. So create account request. Yes, we replied, success. Another request, player login. If there is a request to login a player, we need to check if the username exists. So we go player accounts, player login, and we send the username. Let us see what this does. So the username, player login function takes the username and returns a string. The string that it returns is the salt. And we're going to send the salt to the client so the client can salt the password, hash it with that, and send it back so we can compare it with what's in our database. So we say processing login request for user, and now we are retrieving data from the database. We want to pick a record from the player accounts table, and remember the record keys are SHA-1 checksums of the usernames, not the usernames, the SHA-1 checksums. So we do this, the database retrieve function is here. It takes a table and the key. It checks if we're using the testing backend. Like this will have to be re-implemented later for like PostgreSQL for like deployment, serious work. But for now, I'm using a testing local file backend for the database. So we're checking if the selected table has the given key that is requested. If it exists, then we can retrieve it, and we just return that as a variant. We don't know what it is, but we return it. If it doesn't exist, we return a null. So this is what our database retrieve function does. It retrieves the record, and the record is a dictionary. So if the result is not null, this checks if the result is not null. If it is null, which means the record was not found, we log that and we return an empty salt string, which the client will interpret as whoopsies, account not found. Right, so we retrieve the salt, and you can see we return the result is a dictionary. So we take the item in the dictionary under the key password _ salt, because this result, it has all the player data. We're retrieving the entire player account record. There's everything in it, not just the password salt, but we need just the password salt for now. So okay, our player so far we wanted to log in. We sent the username. The server found that the username exists, found the password salt that corresponds to that username, and is sending it back. So here we're constructing our reply, and it's a reply for the request to log in the player. And we send the result, and the result is simply the result is what our player login function gives us, which is the salt or an empty string. So we just construct this array. Again, we set our target peer to the peer that requested this, because we don't know who was talking to us, and we just send it out with peer put var reply. This goes over to our client, and let's take a look at the client side of the code. So the client when we press on account pressed, on account on player off, on go to login pressed, on login pressed. Yeah, so this is the button that we are logging in. So first thing, we assert that the username is not empty. I had a problem where the username was empty or something, and yeah, that was a part of the debugging. I could delete it, but it won't hurt to just check this. So we put together our request, which is has the header player login. We put our peer ID using peer get unique ID, and we send the username. And then we use peer put var request. Now I'll show you how does the network get initialized. It's very similar to what it was on the server side. We just create a peer init multiplayer peer class. In the ready function, we call infra-connect, which is a method that basically has everything we need to do to connect to the infra server. It connects the signals so we can handle different events, like the fact that we connect successfully, the fact that we failed as a connect, and the fact that the server dropped us, which can happen if the server dies or forcefully disconnects us. And then we create the client. The only difference here is that we specify the address of the server and the port, but not the limit of the peers that can connect to us, because we're the client. Really, this is the only freaking difference. Like, everything else is the same. And then we just print the result in case something's bad. Like, this helps me find out if there's errors. Like, you know, I'm just created the peer twice in a row and it throws error 22, which means I need to just restart the client. It's helpful for debugging, and because this is still a work in progress, I'm gonna keep these. Yeah, this is an old piece of code that I tried, and I explained why this doesn't work, so let's get rid of it. Okay, so that's it. Where does everything else happen? Aha! It happens in this timer. Yeah, let's make this 20 times a second and not 100. The timer is auto-starting, so it just keeps ticking away regardless of what's happening. And everything happens in this onTimer timeout method. First, we check if our peer is either connected or trying to connect. There are 3 possible states. 0 means disconnected, 1 means connecting, and 2 means connected. So in case the peer is not active yet, we just stop here and don't run all the other code. If it is connecting or it's connected, we want to poll our network peer for incoming packets, because if we're trying to connect, we won't know if it succeeded until we poll the network peer incoming packets buffer. If there are incoming packets, same as on the server, as you can see, we read the incoming packet, which is a reply. So on the server side, I call this request. On the client side, I call this reply, because we're always nagging the server to do something for us. The client is always talking to the server, hey, give me this, give me that. And the server is replying to that. So on the client side, I always call this reply. This also helps me see when I'm on the server side of the thing and on the client side of the thing, because the terminology is a bit different. It helps make this distinct. So we check if it's not null, just in case something weird happened. And we check, what's the reply for? Oh, here is a reply for creating account. What happens? Process create account reply. And we just send the payload, which is going to be a number, 0, 1, or 2. And here, if the reply is 0, we do the thing that we did, which is change the text of the button, change the color, animate the color, disable some places, to hide the cancel button, show the go to login button. Yeah, we also hide the create account button from a different dialog because it doesn't make sense to create 2 accounts in a row. We also change the text, and we also start a confetti emission, and then we also start a delayed execution of another confetti, half a second delayed, and we play that. Now, if the reply is 1, then basically the account wasn't found. Oh no, sorry. The username is already taken. And in that case, there is a list of taken usernames, and we add that to the list. And then I run this thing, on username text changed, with the parameter username. This is a function, is a method that's run every single time you type something in the text field for creating account. Well, sorry, gotta hide these. So every single time you type something in this text changed, this username on username text changed method is run, and it gets the new text. And here we are doing the verification. We're checking if there is something in the text field. If there's not, we tell the user to provide a username. And also we mark that there is currently an error with the username. This is very handy because this lets us make sure that the create account, actually we could also make the create account button disabled until these are all clear. That would be a nice thing. Maybe later. Now we also check if the inputted username is in already taken usernames. And we check for all the other things. I need to add @ symbol here too. We also check for all the other things, as well as for the not personal enough usernames. If anything else, if everything is okay, we set the username error to false. Excuse me. Now I'm going to show you what the username false means. So we have these username error. By default, it's false. And there's a setter. So anytime we change the value of this variable, this code gets run. Every single time you change the value. First thing is we check if we are setting the value to what it was before, because every single time you type a character, that method we just looked at is going to run, and it's going to set this to true or false, and it might have been true already. So here we check if there was actually a change happening, because there's no point in running all of that code below if there was no change. If there was a change, we update the value, because the number one thing you can mess up when making setters is forget to actually set the value. If you don't do this in your setter, then your username error will forever and ever stay at false. No matter how many times you try to assign true to it, it's never gonna have the value changed, because you have a setter, and in that setter you did not change the value. I hope you understand this. I have done this mistake, and it's really stupidly hard to debug, so make sure you don't do that mistake. If you have a setter, you have to assign the variable you're running the setter for with the value or something else. Like, you need to set the variable manually. The setter overrides it, and you may think of it like a default setter for every single variable is like this. It just sets the value to what was sent in. But if you create your own setter, you override this, and you need to provide that code on your own, or it's not gonna run. This is really hard to debug. Okay, we're creating a tween. This is for animation. Anyway, we check if the value is true. That means if we're setting the error for true. So if value is true, it means there has just been an error detected in the username field. In that case, we show a username error label. I'm going to show you what that is. username error label, it's here. Yeah. So normally it's not visible, but if you do something that mandates throwing an error, this gets shown. So first thing we show that text, and then this is an extra variable that I needed to make sure that I can reset the state of this form when you cancel out and go back to it. So yeah, basically anything else is just a decoration. This is changing the color of the username field, and this is interpolating, like animating that color so if it flashes red and then it just dims out. On the opposite side, if the value is not true, which means it must be false because this is a boolean, it can only be true or false. This means there is no error with the username, so it passed validation. So we hide the error message and we also make it green and beautiful. And the same is repeated for password 1 error and password 2 error. This code is redundant. These three should be mashed together into something better, but for now it is what it is. So yeah, sorry. And here is create account outdoor colors. By default it's true. And yeah, I'm not gonna, you can track back what that does on your own. Okay, so player auth. We wanted to log in. We wanted to log in. The timer is processing the replies. So we got a reply to create account. That succeeded. Okay, we got a reply to player login. So there are two possibilities. We either got a salt or we got nothing. If we got nothing, this is temporary. I just changed the label on the button to nope, and I unlock the username password edit boxes and enable the login button so we can change these and try again, basically. However, if we did receive something, not an empty string, then we form another request. Now we have the salt. So we create a new request. The request is not player login, it's player auth, so authenticate. Again, we send our peer ID. Maybe this is not mandatory. I didn't find a way to make this better. If you know one, let me know. Or better, submit a peer pull request. I'll gladly take that. Then we send our username once again, just to be sure, and then we send our hash to password. And this is a method called hash password. What it takes is the password and the salt we just got from the server. After this request is put together, we simply send it in. Let's take a look at the hash password method. So it takes the password and the salt. First it notes what time is it in milliseconds, or rather how long is the game running for. It initializes the hash as an empty string, and then it does iterations, and it does these iterations 2 to the power of 12, which is a lot. 2 to the power of 10 is 1024, so 11 is 248, 496. We could do this more. Yeah, but this is 496, 4,096 iterations. And in these iterations, we mash together stuff to make a hash. We put together the password, we put together the salt, and we put the hash that we're creating, and we're combining that all into one string and computing a SHA-256 checksum from that, or cryptographic hash. So after 496 iterations, we have our finished hash. We also check what time is it and how long did it take to compute that hash. Yeah, actually I should do that and this as well. No, this can be, but printing out the password is a bad idea. This was for debugging because I had a really stupid error where I mistakenly somewhere typed hash instead of salt, and I was like, yeah, I think I was like doing this or something like that. I was just hashing with my hash instead of my salt. So logins always failed, which was a really weird error, but I found out what's going on. And then when it's hashed, we just return the hash. Okay, so we got our we hashed the password. We put together our request. We're sending it in. So now what does the server do? The server gets our player authenticate request. What it does, it just forwards it to the player accounts object with the player auth method, and it sends the username and the password hash that we sent. It puts the results of that into the result and send it back. Now, if this succeeds, we're sending back a token. Sorry, I need to blow my nose. I'm a bit sick. Gonna turn down the mic. Nice tutorial, isn't it? Okay, so this should return a new player authentication token. If the authentication succeeded, that is. If it doesn't, we return an empty string, and that means your password is bad, or yeah, but pretty much it means your password is wrong. Let's see what the player auth method does. So here in the player accounts singleton, player auth takes the username and the password hash, and it returns a string, which is going to be the token. First thing is we need to retrieve the username, the user database record again. So we take the SHA-1 checksum of the username as the key, and of course we're looking at the player accounts table. Now we're taking the password, which is result password hash. We're taking the password hash from the database and we're turning it into a packed bytes array. A packed bytes array is a special thingy, var2 bytes. It returns a packed byte array. And this is basically a binary packet. This can be anything. And you can pack variables into bytes, and you can unpack variables or variants from bytes. So you can store, data in binary format in files using this, or you can send it through the network. What I'm using it for is to do a time-safe comparison. So I'm converting both password hashes into bytes, into byte strings, which is going to just be, a bunch of numbers. But if these password hashes match, these packed byte arrays will also match. So I have 1 password and 2 password. Of course, these are hashes, and I need to compare them. I'm creating a new crypto object, which is a class for cryptographic operations that Godot provides, and I'm creating a boolean, which is going to be a result of our comparison. And then I'm running crypto.constantTimeCompare, and I pass both packed byte arrays. The constant time compare is a special method for comparing packed byte arrays that is not going to leak any information, any timing information when comparing. So no matter if these match or don't match, a third party will not be able to detect it by, measuring how long the check took. This is to guard against brute force attacks where you try to, spam a bunch of stuff and then determining how long the reply took, you can find what matched or what was closer to matching or something like that, you know. And this prevents it. So you can't just put a bunch of stuff and then graph the time that it took to reply for the server to reply and figure out which is the closest candidate and, you know, brute force smarter. I'm not a hacker, so I have a very rudimentary understanding of this. If you know more, please let me know. I'd love to know. So we check if these password hashes match. If they do match, we run this. If they don't, we run this. So if they don't match, we return an empty string, and that means your password is wrong. If they do match, however, we generate a token. The token is pretty much a random string that it's just something unique, something that can't be forged. No one can figure out this random token because it's just super random. And what we're going to do is we're going to send this to all the game servers and to our client, and then our client just sends this token to the game servers, and the game servers already have this token in their list and say, okay, come in, I know you. Instead of, you know, sending their password hash to them and log in and going for all the authentication everywhere. No, they just authenticate once with the infra server, get the tokens, and then they just send the token to the servers, to the game servers, individual game servers where they're going to play a match, and that speeds things up and makes it safer because we don't need to keep sending password hashes, etc. We generate a token for the given username, and actually it could not need to be used at all, but I'm using it to like put a little extra in it. And we put that into the database, and there's a special method I created, store user token, and then we return the token. Let's take the generation of the token. Generate token. First we randomize, so we initialize the pseudo-random number generation in Godot with the current clock, and we generate a string which takes the random integer. It's going to be a huge number, like a 64-bit number. So pretty much we had 64 random bits. We add the username as well, and then we compute a SHA-256 checksum from that, or the cryptographic hash, and then we append the current Unix time from the system. And this together is a long-ass string that is going to be our token. We return that. And now, what we can do, let's go back to player off. So once we do have this token, which is here, we put it to our database, and we return it so it can be sent back to our client. Putting it in the database is pretty straightforward. Store user token, you say the user, you say the token. Again, it's only implemented for the testing database backend because that's the only backend there is right now. And this is a specialized function. So it just looks for the username using the SHA-1 hash, of course, as a key. If that exists, we just put the token into the tokens array inside of our username record, of our user account record. And also we put it into the global tokens table in the database. After that, we trigger a save testing file so that the database is stored on disk immediately, so that if we lose power or the software crashes, this is not lost. That's important. We don't want to lose that. And you can see to distribute the new token to all game servers. This is important because that's the whole point. It's so the game servers can identify players and authenticate them because they bear the known valid tokens. And if that all worked out, so we managed to store the user token successfully, we return a 0. And there is an option that for some reason we make an error and we try to call to store a user token, but we give a bad username, or we just forget something. So I'm also made a case for that. This may be helpful if if we're gonna have some errors later. And we return an error code. Okay, so let's go back to player accounts. Yeah, we return the token. What happens next? In the infra server script, we generated a token or an empty string. We put it together as a reply to the player auth request. And once again, we set our target peer to the peer that sent in this request. And we send back our reply. And this is everything the server right now can do. It can create an account. It can log you in and create a token and send it back to you. That's all. And it's quite complex, but not that complex when you break it down. Right. Okay, and player auth. The last thing the client can do is receive the player auth reply for the player auth request. And then it's checking. Did it get a token or did it get an empty string? If it gets an empty string, that means that the password is bad. If the username was bad, it would have an error here. Okay, I'm gonna make this more memeful and do it like that. Right, so because first we send the username. If the username is correct, we can get back the salt. If we send a correct password hash generated using that salt, we get logged in, we get a token. So if the login is successful, well, that is success. And what you really need to do after that is there is an array here called tokens, and I'm going to append this token. So it's going to reply 1. So this is the payload. Right, and later, this is going to be used to authenticate with the game server. So you join the match, and the server asks you, hey, you have a token? And you say, yes, I have. You send this in, and they say, okay, you're an authenticated user. And also, the game server can send this token to the infra server and like fetch your data from the server, and it can verify that this data is correct, that you're not lying about your account or something, So it can fetch things like your badges, etc., your achievements, your cosmetics, whatever. And the game server can do it without your intervention because it knows you, and it can authenticate you, and it can identify you and talk about you to the infra server. But this all is going to come in later. I had a lot of fun making this. I think like my brain is twice as large now as it was before I implemented all that. And I learned a lot of things. And I made a lot of mistakes, and I've solved a lot of them. This player auth script is not the best one. It's quite huge, monolithic thing. There's code duplication. Everything's in a one scene. It's really big. It will need to be broken down, cleared up, and overhauled a little bit, probably refactored basically. But I think it does the job. It works, and it's a solid foundation for the future work, which I'm really excited to see. Yeah, so if you would like to help us make this game, and you'd like to join the Liblast team, all the links are in the video description. Liblast is a free and open source first-person shooter multiplayer game that is being developed mainly by myself, but also by a couple of contributors forming a Liblast team. And we're always looking for new contributors, especially people who can program in GDScript, because there's lots of coding to be done. We've got some programmers, we've got some artists, we've got some animators, we've got some DevOps people who help maintain websites and stuff, but we're looking for GDScript programmers as well. So if you'd like to get involved in a project that honestly, it's really fun. You can, learn with people, work with people, get some experience making games, have some fun. Yeah. You know where to find me. Okay, that's all. See you later.